Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce, Soundarya Institute of Management and Science, Bangalore. Now I am going to explain standard deviation. It is a very important tool of statistics, will be used for the higher studies. This topic will be under the measures of dispersion, unit number 4. Subject is quantitative analysis for business decision 1. In general, we can say business statistics of Bangalore University syllabus, second semester BCom and second semester BBA courses. Now I am going to explain your standard deviation, meaning, definitions, formula, merits and demerits, then how to solve the standard deviation problems in three different types of data. First one is individual series of observation, second one is a discrete series of observation, third one is continuous series of observations. Standard deviation, coefficient of variation we are going to study. It is defined as the positive square root of the arithmetic mean of the square of the deviation of the given observation from their arithmetic mean. In simple way you can say square under the square root of the deviation from the arithmetic mean, then we can say it is called as standard deviation. Previous one we studied mean deviation. The same way we are going to use, the sign will be neglected. We are not going to be neglect. We are going to take a squaring and automatically it will become positive value. That is what we are, the definition says, positive square root of the arithmetic mean of the square of the deviation of the given observation from the arithmetic mean. That is the way we can study here. Calculation of standard deviation for individual series. There are two methods will be followed. One is deviation from actual mean, deviation taken from assumed mean. But we are going to study maximum actual mean only. Through the formula we are going to be calculated and we are going to be solve the problems. These are the formulas. The simple way to remember sigma, it is a notation for the standard deviation, square root of summation d square divided by n. For discrete and continuous series of observations, we will write sigma, that is standard deviation, equal to square root of summation f d square divided by n, capital N. This already we studied, so we are going to use this under square root is a new concept. Merits. It is rigidly defined and its values always definite and based on all the observations, like a mean we are going to be calculated and the actual sign of deviations are used. As it is based on the arithmetic mean, it has all the merits of the arithmetic mean. It is the most important and widely used measures of dispersion. In further any statistical studies or any testing of hypothesis, standard deviation plays important role in statistics. It is possible for further algebraic treatment, testing of hypothesis, distributions, and all we can able to use. It is less affected by fluctuation because everything will be accurate and definite. The values are exactly will get, so that there will be less fluctuation of the sampling. Therefore, it is stable. It is the basis of measuring of coefficient of correlation and sampling for the further analysis. Demerits. It is not easy to understand and is difficult to calculate. That is another one problem too. The people who are very much involved in the subject, then they can able to understand very easily. Otherwise, it is little bit confusion and making a clear ideas and accurate values. It gives more weight to extreme values because the values are squared up. That's another one drawback. As it is absolute measure of variability, it cannot be used for the purpose of comparison. That's the another one problems are facing in the standard deviation. Coefficient of variation. The standard deviation is an absolute measure of dispersion. It is expressed in terms of units in which the original figures are collected and stated. The standard deviation of heights of students cannot be compared with the standard deviation of weights of students. Height in centimeter and weights in kilograms, therefore standard deviation cannot be converted into relative measure. Same kind of measures only can be used. Therefore, the relative measure is known as coefficient of variation. B. What is the formula? Mean standard deviation divided by mean into 100. That is the formula to find a coefficient of variation. Is one problem. This is individual series of observation. How to find standard deviation, coefficient of standard deviation, then coefficient of variation. The given values will be written in the horizontal form into vertical form. So all we written here. First we need to find out mean. Always standard deviation based on mean. Mean continuation process is called standard deviation. Mean is the basis for the standard deviation. So first we need to find out mean. Mean for individual series of observation is summation x divided by n. Sum of all the values divided by number of values. Sum of all the values 4 plus 9 plus 11 plus 12 plus 17 plus 5 plus 8 plus 12 plus 14. All these values added, we will get 92. Number of values is given 9. So divide it, we will get as 92 divided by 9. So 10.222. For the convenience of our calculation, we are making as a round off. So that is called 10. So we will use it as deviation based on mean value as 10. So D, small letter D here, because differentiating from mean deviation to standard deviation. Mean deviation equal to x minus x bar. This column as it is what we did in the mean deviation concept. So here 10 is the mean we have considered. So 4 minus 10 minus 6, 9 minus 10 equal to minus 1, 11 minus 10 equal to 1, 12 minus 10 equal to 2, 17 minus 10 equal to 7, 5 minus 10 equal to 5, 8 minus 10 equal to minus 2, 12 minus 10 equal to 2, 14 minus 10 equal to 4. Then squaring of this value. 6 square 36, 1 square 1, 1 square 1, 2 square 4, 7 square 49, 5 square 25, 2 square 4, 2 square 4, 4 square 16. All the d square values are added. Summation d square equal to 140. Now standard deviation formula will be used. Square root of summation d square divided by n. Summation d square here 140. D is 9. So 140 divided by 9 is square root of 15.555. Square root of 15.55 will get 3.9439. This is the way we will be calculated standard deviation. Now it is the basis of any statistical analysis in future. Mean is more important. Based on the mean, we are going to be find out standard deviation. Now mean are found, standard deviation also we found. Now coefficient of standard deviation and coefficient of variation we will find out. Coefficient of standard deviation. Standard deviation divided by mean. Standard deviation value 3.9439. Mean value 10.222. So actual value only you have to take. Rounded value we should not take. Approximate value only for the table calculation. So after dividing that, we'll get 0.38582. Then coefficient of variation. Coefficient of variation equal to standard deviation divided by mean into 100. So we'll get 3.9439 divided by 10.222 into 100. dividing that value 0.38582 into 100, so we'll get 38.582 percentage. Always coefficient of variation will be written in the percentage. This is the way we need to be calculated individual series of observation. So variance, suppose variance is given, how to find? Variance equal to standard deviation square. Standard deviation equal to square root of variance. Both the way we can find out. Here standard deviation we know, variance we can able to find out. 3.9439 equal to 15.555, that is the variance. Variance is given, we can able to find out standard deviation. Standard deviation is given, we can able to find out variance. Now discrete series of, here another question will be taken and consider of discrete series of observation. The discrete series of observation will be written in the vertical form. So will be written as, then finding total of frequency 100. We know very well in standard deviation we need to find out mean. So mean we have to find out, the formula is summation fx divided by n. Then f into x will become multiplied 8 into 12 96, 16 into 14 224, 18 into 16 288, 26 into 18 468, 16 into 20 320, 10 into 22 220, 6 into 24 114 144. All the fx column total, that is 96 plus 224 plus 288 plus 468 plus 320 plus 220 plus 144, will get summation f and x total 1760. Now this, using this value we will find out mean. 1760 divided by 100, simplify 17.6. Then for the purpose of calculation we will use approximate value of mean equal to 18. Now deviation we need to find out. D equal to x minus x bar. D value x minus x bar. X is given values of x column, consider, and then mean value consider. 12 minus 18 minus 6, 14 minus 18 minus 4, 16 minus 18 minus 2, 18 minus 18 0, 20 minus 18 2, 22 minus 18 4, 24 minus 18 6. Then square you have to take d square, 6 square 36, 4 square 16, minus 2 square 4 0 0, 2 square 4, 4 square 16, 6 square 36. Here if you get deviation value in negative, squaring time obviously will get positive. Then total of that we need to find out. Then f into d square, because formula of standard deviation is square root of summation f d square divided by n. Here f into d square we need to multiply. F column and d square column multiply. 8 into 36 288, 16 into 16 256, 18 into 4 72, 26 into 0 0, 16 into 4 64, 10 into 16 160, 6 into 36 216. So total of this value, that is 288 256 plus 72 plus 0 plus 64 plus 160 plus 216. So total will get 1056. This is the way we need to find out summation fd square. Standard deviation equal to square root of summation fd square divided by n. Summation fd square value is 1056. Capital N is total frequency 100. Then simplify 10.56. Square root of 10.56 will get 3.2496. This is the standard deviation value. Once we are finding standard deviation, then coefficient of standard deviation you can find out. The formula is standard deviation divided by mean. Standard deviation equal to 3.2496 divided by 17.6 the mean value. Then simplify 0.1846, that is a coefficient of standard deviation. Once the coefficient of standard deviation can find it, then we can go for the coefficient of variation. Coefficient of variation formula is standard deviation divided by mean into 100. Standard deviation value 3.2496 and then mean value 17.6 into 100. Simplify 0.1846 into 100. Then we'll get 18.46 percentage. Or you remember that I told that previous series of observation explanation, coefficient of variation will come under percentage at last. Then variance we know very well, standard deviation square. Here standard deviation value is 3.2496 square 10.56. This is the way we can able to find out discrete series of observation, how to find standard deviation, coefficient of standard deviation, then coefficient of variation. Now I am going to explain continuous series of observation. The same procedure what we studied in the discrete series, same procedure we are going to follow. That's what is a slight changes here. Continuous class interval, we need to find out midpoint. Again I will repeat it. Whatever we studied in the third unit, measures of tendency, same thing. Whatever you studied, that is all we are going to be apply here. Same logical, same type of data conversion. The given problem will be written in the vertical form. Here frequency will be added, n equal to 100. Now we know very well this is a continuous class interval, so we need to find out midpoint for the purpose of mean finding. So we need to find out midpoint. 40 plus 60 divided by 2. 60 plus 80 divided by 2, like that we'll get 50, 70, 90, 110, 130, 150, 170, because the class interval difference is 20 is there. Then f and x will be multiplied. 6 into 50, 300. 10 into 70, 700. 18 into 90, 1620. 30 into 110, 3300. 15 into 130, 1950. 12 into 150, 1800. 7 into 170, 1190. Total of fx column, that is 300 plus 700 plus 1620 plus 3300 plus 1950 plus 1800 plus 1190 will get 10,860. This is the total of fx column. For the purpose of mean, will we find out. Already we studied that mean how to find. Here there is no place for the remaining calculation for the purpose. Next slide I did it. Now I am saying explaining that mean equal to summation fx divided by n. Summation fx is 10,860 divided by 100, 108.6. For the convenience purpose, we are using 109 for the deviation. D equal to x minus x bar. Mean value is 109. That explanation will be shown in the next slide. So 50 minus 109 minus 59, 70 minus 109 minus 39, 90 minus 109 minus 19, 110 minus 109 equal to minus 9, 130 minus 109 equal to 11, 150 minus 109 equal to 31, 170 minus 109 equal to 51. So this square it, 59 into 59, 3481, minus 39 into minus 39, 1521, 19 into 19, 361, 9 into 9, 81, 11 into 11, 121, 31 into 31, 961, 51 into 51, 2601. Then one more column we need to find f into d square. 6 into 3481, 20,086. 10 into 1521, 15,210. 18 into 361, 6498. 30 into 81, 2430. 15 into 121, 1815. 12 into 961, 11532. 7 into 261, 18 into 18,207. Total of FD square value is 76,578. This is the way we need to calculate and fill the tables. Now you can see the mean formulas, what I explained in oral. 10,860 divided by 100, then we'll get the 108.6, then approximately we'll find out 109. That is the one way. Now standard deviation formula we know. Square root of f summation of d square divided by n. 76,578 divided by 100. The values we found it. Then divided by 100 means 765.78. Under the square root of that, we'll get 27.6727. This is the standard deviation of the given problem. Now coefficient of standard deviation. Standard deviation divided by mean. So 27.6727 divided by 108.6. Simplify 0.2767. This is called coefficient of standard deviation. Once we find it, then we can go for the coefficient of variation. Standard deviation divided by mean is, we are going to find out, then values will start substitute. Standard deviation is 27.6727 divided by 108.6 into 100. Simplification of that, 0.2767 into 100. So 27.672 percentage. It is called as coefficient of variation. Variance equal to standard deviation square. So value we can use it. 27.6727 square equal to 765.78. So this is the way continuous series of the problems will be solved by mean, standard deviation and coefficient of variations problem. Thank you for watching. Next video will be continue. Thank you so much for watching my videos.